Arliss and Lontok, and today my group and I will be reporting on the bionic spine. Now, what exactly is the bionic spine? The bionic spine is a bioelectronics device that has been developed by Australian researchers in the University of Melbourne. And what the bionic spine does is it creates a brain-machine interface between the human mind and a machine connected to it. In this case, the machine connected to it is a bionic limb that works in tandem with the human spine. Now, what exactly is the purpose of this bionic spine? According to the research group that created it, the main purpose of this bioelectronic device is to serve as a substitute for the regular human spine. Basically, it will allow paralyzed patients to walk again because this bionic spine will be able to replicate the activities and functions of the normal human spine. And now, to provide a more detailed explanation on the bionic spine's functions is Mr. Aleksander Malate.
The bionic spine, the doctor will make a tiny cut on the neck of the patients and feed them a tube containing the device. This will go to the blood vessels leading up to the brain until it rests at the top of the motor cortex. The motor cortex is the part of the brain responsible for the voluntary movement, and then after which, the tube will then be removed, leaving the bionic spine only behind. The centerpiece of the bionic spine's BMI, the stent rod, will begin its work. The stent rod is a stent-placed electrode that contains the 3 cm long stent that has 12 electrodes. The stent rod receives neural signal that initiate movement and then send those signals down to 12 microbits into a computer interface, which then translate the signal information into a movement of our body. Now, talking about ELSI will be presented by Lontok.
Like most bioelectronic devices, the bionic spine has its own ethical, legal, and social issues which obstruct its development and widespread usage. First of all, the device has only ever been tested on sheep, and while the bionic spine will be fitted on 3 patients in the Royal Melbourne Hospital next year, only time will tell if the results of this test run will be successful or not. Also, the fact that animals were used in the testing of the device may cause the bionic spine to earn the ire of several animal rights groups. We're also concerned of the fact of the bionic spine being rejected by the patient's body, which may cause the patient's condition to worsen, a situation that can potentially lead to the patient's death, and also a situation that one may be unwilling to risk on to the point of refusing to use the bionic implant. To give our conclusion on the bionic spine is Mr. Ulaye.
Previously mentioned details and facts, we have concluded that while the bionic spine is definitely a promising invention that can potentially cure the problem of paralysis, the device still has a long way to go before becoming a fully functioning and publicly available medical solution. The reason for this is the lack of proper human testing, which won't be started until sometime next year. As such, until we see the positive and promising results from the upcoming testing, bionic spine's next stage of development will most likely be postponed until further notice. Despite these statistics, however, the mere fact that the bionic spine has been invented shows that the field of bioelectronics is continuing to expand at a rapid pace. It also means that in the near future, more complex medical inventions made possible by bioelectronics have a possibility of being made available to the general public.